the converse of the Pythagorean Theorem basically says this: if c squared equals a squared plus b squared, then we know the triangle is right. If c squared is greater than a squared plus b squared, so if c squared is greater than a squared plus b squared, then the triangle is obtuse. And finally, if c squared is less than a squared plus b squared, then the triangle is acute. Alright, so let's try it out on some lengths that could or could not be triangles. So first off, decide if it's a triangle. If it's a triangle, the two smaller numbers have to add up to be larger than the third number. So here you have 4 plus 6. 4 plus 6, that's 10. 10 is greater than 8. We know it's a triangle. So that's the first test you do. You know, the teacher could have made a bad problem and you can point that out to them, or they might be trying to trick you on purpose just to see if you're paying attention. So we plug this in. C is always the largest length. So that's always, it could be the hypotenuse if it's a right triangle. So 8 is C. So I'm going to go ahead and I've got c squared something equals a squared plus b squared. We're going to decide if this is equal, greater than, or less than. So 8 squared and then something. 4 squared plus 6 squared. We don't care what a and b are. Alright, so that's 64, and that's 16, and that's 36. And so 64 and 16 and 36 is 52. And notice it's greater than. This is an obtuse triangle. We know it's an obtuse triangle with those three lengths. And they could be in inches, they could be in feet, miles, whatever. But we know those three lengths will form an obtuse triangle. Next example, 1, 4, and 10. Okay, again, check to see if it's even going to be a triangle. And you notice 1 and 4, that's 5. Well, heck, that's less than 10. There's no way. You know, here's a way to think about that. Okay, if this was 10 inches, say, if that's 10 inches, and this probably would represent 1 inch, and this length would probably represent 4 inches, there's no way that the 2 points could meet. No way in heck. So we need these two to, we need one or either of those to be longer, or 10 to be shorter to make a triangle even. So this one's not a triangle. Okay? Alright, we're going to skip this one for now, but we'll come back to it. Okay, 6, 7, and 8. So again, 6 plus 7, 13, greater than 8, we're good for triangle. If you go in here, 8 squared is, again, your hypotenuse, possibly. 7 squared plus 6 squared. So 64, 49, 36. Add these two together. So 64, 9 and 6 is 5. Carry the 1. 85. 64 is less than 85. So we know, therefore, this is an acute triangle. Now I'm going to kind of speed along because I only have 5 minutes to get this. So there's an example of what would acute triangle be. Now let's go to the final example. Okay, you may not know, I threw a root in there just to make it a little more difficult, but you may not know what 4 root 3 is. Type that into your calculator. See if it's bigger. Maybe it's bigger than 8. Who knows? Sorry, I picked 8 for the hypotenuse every time. It doesn't usually work that way. You know, you also want to check to see if this is a triangle. Add 4 plus 4 root 3. For right now, I'm just going to, because of time constraints, it works. And 8 is your biggest one. So it'd be 8 squared equals 4 plus 4 root 3 squared, the entire thing. So we'd have 64, whoops, that should be 4 squared, 16, plus, now you got to square everything in here. So that's 16 times 3, because a square and a square root end up crossing each other out. That's 16 times the root of 9. So 16 times 3. I'll let you finish this one out. It's going to be a right triangle.